Everybody say hi, Libby, Luke, and Jalen.
Hi, Libby. Hi, Jalen.
They don't care about Luke. Okay. Anyway, so this is section 3-4. We skip a mid-chapter quiz for this chapter, just FYI. There are only 5 sections in this chapter.
Oh, no.
Okay. It's a short, really quick, speedy chapter because it hasn't been too terribly difficult. No, there is no mid-chapter quiz. It's just like we skip the mid-chapter quiz, but we will be testing over chapter 3 like by the end of next week, probably like Friday. Okay. So yeah, like next week, Friday.
I'm gonna be dead.
So 3-4 is a composition of transformation. So it's doing like all 3 of these, kind of like 2 of them at the same time. Okay. So at the top of your paper, put these 3 things. 3-1 is reflections. 3-2 is translations. 3-3 is rotations. We're going to put a summary of stuff up here at the top of the paper. Okay, we'll go over those guys. Okay. Reflections. There are 3 types of reflections that we did. They are the x-axis reflection. They are y-axis reflection. And they are reflection over the line y equals x. We're going to write those rules over here. Okay, we'll write the rules for each one of those. Okay, reflections, translations, rotations. So 3-4 is doing like 2 of these at one shot. Okay, and it's not terribly difficult. It's really kind of the same difficulty level. Okay, multiple things. Okay. All right, so let's see if you can remember these. If you're reflecting something across the y-axis, what do you do with the coordinates?
You flip them and
Nope, you don't flip them. Just the y becomes negative.
Okay.
Just the y becomes negative. Rotation is when you flip them.
Wait, the
okay?
x and the y-axis, which...
Over the x-axis, the y becomes negative.
You said the
Okay.
y-axis at first, and I was like...
Oh, sorry. X-axis, the y becomes negative. Y-axis, the x becomes negative. Okay, what about the line y equals x?
You flip-flop them around.
You flip-flop them around, so it's y and then x. Yeah. You betcha. That's the rules for when you're reflecting things, okay? So write this at the top of your paper so you can just cheat off of this as you do these. These are the rules, okay? Translations is the easiest section out of the 3 sections because when you're doing translations, you have this this thing right here. These are triangular brackets. And this guy tells you left or right, depending on whether it's a positive or negative, and this guy tells you up or down. So... and that's all you have to remember. Translations is just sliding things. So depending on which number is whichever one, it tells you left, right, up, down. That's translations. Okay. And then for section 3-3 is rotations. So we had a 90-degree rotation. We had a 180-degree rotation. And we have a 270-degree rotation. And each one of these rotations is counterclockwise. CCW is what they'll write for short. Counterclockwise. All right, so let's write out what you do to each coordinate when you have 90, 180, 270. Okay? All right, 90 and 270 are very similar to each other. What do you do for 90, 270? You flip them, okay? So y, x. You flip them on each one, 90 and 270, but only one coordinate becomes negative for 90 and 270. Which one is it for 90?
Y.
Like the first one, right? The y, right? Okay. The second one, 270, it's the second coordinate, right? Because 90 comes before 270. So they're flipped on both of them, yeah. But the negative goes with the first coordinate on 90 because it comes first. With 270, it's the second coordinate, right? Okay. And then what's the rule for 180? Do you remember? They stay the same, but they become negative. So it's negative x, negative y. Right? They stay exactly the same, but they become negative. Okay? I get the 180 confused around a lot with reflection over y equals x. So here, you're flipping the x and the y. Here, they're staying in the same spot, but they become negative. So that's kind of a little bit confusing. But here is your cheat sheet at the top of this page. This is your cheat sheet to know, like when we're doing multiple ones, what you do. Okay. All right. So compositions of transformations is like doing 2 of them at the same time. So this thing is called, in this box right here, they have a picture of a glide reflection is what it's called. And this is a reflection and a translation. Okay. We'll do one of these at on the very, very back page. Okay. So what they've done is they've taken this foot, this is my first foot, and they reflect it over to make it go here, and then they slide it to make it go in that spot. And then they flip it over again, and then they slide it to get the next image. They flip it over again and slide it, and that's kind of how you get footsteps. So to go from one image to the next, you have to slide it and reflect it. Slide it and reflect it. Slide it and reflect it. Okay. And that's called a glide reflection. Okay. All right, let's go down here. List off your JKL. This is a triangle. JKL. I'm going to move him down a little ways. Lasso. I didn't know I could do this until like this morning. I figured that out. JKL. 6, -1, 10, -2, 5, -3. There's that. Okay, and the first thing that we want to do to that is, do you see? We're doing two things. Do you see what we're doing first?
Translation and reflection in the Y.
Yep, so 0, 4 is what we're doing to it first. How does that move it, by the way?
You just pretty much like adding.
Up 4, right?
Yeah.
Up 4 is what you're doing. Okay, so we're going to write those coordinates out, and then we're going to write out the last coordinates. Okay, we're going to skip a lot of this graphing stuff, so, because I trust that you know how to graph. Do you know how to graph?
No.
Okay, we'll graph a couple of them, but anyway, we're going to skip this graph, so don't graph it yet. No, you got to do the graph. Sorry, I'm just trying to make it go faster. Okay.
We're doing speed, guys.
We're doing speed. Okay.
I love speed.
I hope not.
I bet he doesn't. Okay, anyway. All right, so these guys, so going from, I have them kind of color coded, going from the pink to the yellow, it's J prime, K prime, L prime. Is that a yellow? Is that yellow?
That's orange.
Okay, mine's yellow on here.
Okay.
I don't know. Anyway, and then going from yellow to green or gold, orange, whatever that color that is, this is called J double prime, K double prime, L double prime. Yep, because you're doing two of them. I don't know why this guy has a double prime on him already. Anyway, so primes and double primes because you're doing two of them. Okay, so if I'm going 0, 4 from my original ones, if I'm starting at 6, -1, what's my new coordinate?
0, 3. Or no, 0, 3.
6, 3, right? The next one?
10,
2.
10, 2, and 5, 1. Okay. Now, if I'm going over the y-axis, what's the rule?
Negative XY.
Negative xy. So the x coordinate becomes negative. If it's already negative, you make it positive. So what's 6, 3 change to? Negative 6, 3, negative 10, 2, negative 5, 1. Okay. And that's what those guys are. All right. And then we graph them, but we're not going to because we're going to skip it. Okay. Because I trust that you guys know how to graph. All right. Good?
Yeah.
Okay. Anytime you are doing a composition of these, it's called an isometry. Okay. So compositions of 2 or more is called an isometry. So 2 or more transformations is called an isometry. Make sense? Good? That's just kind of an interesting vocabulary word. Okay. Now we have a line this time that we are flipping him over, and C, D are my 2 coordinate points. And we start with -7, 1. We start with -3, 2. And first we are reflecting him over the x-axis. You see where it says that? And that's C prime, D prime. We're going to figure out what those coordinates are. And then from that one, we're going 90 degrees. And we're going to write out what C double prime, D double prime, D double prime is. Okay? All right. Okay, what's the rule for over x? X negative y. You just take the y coordinate, make it negative. Okay, so -7, 1 becomes -7, -1. Yep. What about -3, 2? -3 and -2. Okay. All right. Now a 90-degree rotation. They flip. So y, x, and the y becomes negative, or the first coordinate becomes negative. So if I flip them, it would be -1, -7, except it changes to +1. Okay. If I flip the D ones, it would be -2. Whoop. -2, -3, but that's going to change to a +2. Okay. Let's go ahead and graph these guys because they're only 2 points. So, -7, 1, -3, 2. There's this guy here. Going to the next one, and this one, and this one, and we're connecting those dots. Okay, so if you can see that, I just flipped him over the x-axis, so he went straight from there to there. And then I'm going to rotate him around, and he's going to do this. He's going to rotate 90 degrees around this way to become in that spot. Do you see how they've done that? They flipped him down, and then they're rotating him around. So that's what he will look like. Happy with that?
Yeah.
Good, good, good. Okay. All right. We're going to skip some of this next stuff. Like I think they have us do. Nope, we're going to do the next one. A, so go to the flip to the back side. We're going to go straight to example 3 because I'm going to show you with an example what they're talking about with 3-3 and 3-2, that stuff, okay? So here's the deal. Part A on number 3, okay? I'm not going to make you guys get the index cards out and measure these exactly, so just do your best, like guesstimating and drawing these. The first thing that they want us to do is they want us to reflect him over line M, okay? So what I'm going to do is I'm going to look at like the distance here, and I'm going to put that vertex at the same spot on the other side, okay? So we want to kind of go straight across. So if I go from here, if I'm going straight across, I'm going to put him like, I don't know, that dot maybe right about there, right? I'm going to take this dot, I'm going to put him straight across, but I'm going to put him about there-ish, okay? And then that one straight across. So just kind of eyeball these. I realize that it's kind of hard to do, I guess. So you're doing this, something of this nature. That's what he's going to look like. Kind of like a diamond, but he's bigger on one side. Okay? You're going like straight across. I'm trying to put those dots in the same spot. Okay? You're going over line M. So just kind of eyeball him. Good? Now we're taking this figure and we're flipping him over line P. Okay? So he's going to go over there a little bit. All right? So I see that this is like this distance away from that line. So I'm going to go the same amount, and he's going to be over here just a little ways. Right? Over there, about over here, about up there, and about down here-ish, something like that, right? Something like that. Just do your best. He should stay about the same shape and same size, so try to make him the same shape, same size if you can. Okay, mine kind of did a little bit. Okay. He's just the same distance, but on the other side, okay? Now, in this problem, we did 2 reflections, right? We've reflected him and then reflected him again. But they are saying then describe a single transformation that maps the first one onto the second one. This is my A double prime. This is my second image. So what could I have done to go straight from here to here rather than flipping him and flipping him again? I could have done one translation, but how much? How much would I have to slide him over? Is it 1.75 centimeters?
No, it's more than that.
It's more than that. How much more than that? Any ideas? It is going to be twice the distance. Twice the distance that those 2 parallel lines are from each other. That's how far apart you're sliding them. Always. Always. So you just double that distance in there. What's 1.75 doubled? 3.5. 3.5 centimeters. He is slid to the right. Okay. So I could just slide him that many units in whatever direction they're asking me to do, right? Mm-hmm. Translation 3.5 units right. So 2 reflections across parallel lines equals 1 translation, but 2 times the distance. Okay, and circle that really big because that's going to be the important part. Okay, your graph isn't necessarily I mean, your graph is important, I guess, but some of your graphs are going to be really gross and disgusting because we're eyeballing this. Woo! Something just happened. Come on. I just moved my cable. Okay. Oh. Okay, there we go. We're still going. All right, so there's that. Make sense? So that's the big important part. Make sure you have this guy written down over here. That's the biggest, importantest part. Okay, let's go to part B. And now they're wanting us to reflect it over M again and reflect it over P. But instead of having 2 parallel lines, we have 2 lines that are intersecting at a 60-degree angle. So let's talk about that here. Let's flip him over. So I'm going to do like this distance, the same on that side. A, I want him to go straight across. So A is going to be like maybe-ish about there. And this one's going to go straight across. You guys remember when we did like our perpendicular lines?
Mm-hmm.
You want him to do like about that much, right? Okay, so there's my lines there, and this is what my new shape is going to look like if I reflect him that direction. So something like this, just do a little rough sketch. He should kind of look the same after you flip him over. Whatever. Okay, then as soon as we've done that, we're going to reflect him over P. So I'm going to put him, that dot there. I'm going to move this one up just a little bit. I don't know, like there-ish. And this one over to about, I don't know, here-ish. And here's going to be my new triangle. So this is going to be my A double prime. Here's A prime. This is my shape A prime, and here's my A double prime. So there's that. I flipped him, and I flipped him again. Okay, and it should be about the same shape, same size as what he was to start with. Okay, but now I have to describe like one single thing rather than flipping him and flipping him again. What's one thing that I could have done instead to get him from here to here?
Rotation.
Yeah, you can rotate it, right? From here to here. How much would you have to rotate it? Whoop. Rotation of how much?
180.
You're kind of close.
Oh, wait.
Look at the angle that we have. That's a 60-degree angle in between those two lines. So 120. A rotation of 120 is always double the amount, right? Okay, because it's going to be a little bit more than 60 degrees, right? Okay, but it's going to be a rotation of 120. So two reflections, in this case, when they're intersecting, two reflections equals one rotation of 2 times the angle measure. Okay, one reflection equal, or two reflections equal one rotation of 2 angle measures, or 2 times the angle measure. Okay, that's when your lines are intersecting and you're reflecting it twice. Okay, over here my lines were parallel, so I could have just slid him over, right? 2 reflections equals 1 rotation. Make sense? Good? Okay, all right. I can't draw flowers, so we're gonna skip this next part, part A, but we are gonna do part B, okay? We are gonna do part B. So part B though, they say whatever my original one was, whatever original A, B, C, and D were, okay? We've got to find the original A, B, C, D. But A, B, C, D, whatever, we took that thing and we reflected it. Oh, let me go a different color. We took it and we reflected across X axis, and we got a new A, B, C, D. Then we took that guy and we reflected him over the Y axis, and we got our final A, B, C, D, and they're giving me the final A, B, C, D. You see that? Okay, they give us the final A, B, C, D, which is -1, -1, -2, -4, -4, -4, and -5, -1. There he is. Okay, so if we want to work backwards, we've got to like do the transformations backwards. So we're going to do the y-axis first to get him back to these pink ones here in the middle. Okay, so we're going to undo that y-axis transformation first to get him back to the pink ones in the middle. Okay, what's the rule for y-axis? Am I going too fast?
No.
What's the rule for y-axis? Over the y-axis.
You do negative x, y.
Yeah, so you just make the x coordinates negative, okay? If they're already negative, you make them positive. So if I undo my y-axis stuff, what does he become over on the middle one? -1, -1 will become
Or positive 1,
+1, -1, okay? -2, -4,
positive 2, negative 4.
+2, -4, -4 will be +4, -4, and then
Positive 5, negative 1.
+5, -1. Okay, now let's do the next one.
X-axis is x, negative y.
Yep, so the x-axis, we just make the y coordinates negative. So if I'm undoing that, I just flip them back positive again, okay? So A will be
1,
1, 1,
2, 4,
2, 4,
4, 4,
4, 4,
5, 1.
and 5, 1. Okay? All right, now, we're not going to graph this. I trust that you know how to graph these, so we're going to skip the graph. But look at the difference between this guy and this guy. Is there one thing that we could have done rather than flipping them twice? Is there one thing that we could have done? Right, so 5, 1 became negative 5, negative 1. What rule is that?
180-degree rotation.
180-degree rotation. So rather than flipping them twice, we could have done 180-degree rotation. Do you know why it's 180-degree rotation? These lines are making what angle with each other? A 90-degree, right? 90-degree rotation, or 90-degree if we double it is 180, right? Does that make sense? Okay, good? So just going from one to the other could just do 180-degree rotation. Let's go down here and, I forgot to erase. Let's go down here. Let's go to B. I can't draw flowers, so we're just going to skip part A. But let's go to B, and they say, what are you doing from one to the next? Okay, just FYI, this is image number 1. This is number 2. This is number 3. This is number 4. This is number 5, and this is a composition, right? So it's like we're doing two things at this kind of at the same time. Okay, so how do I get from image 1 to image 2? I have to slide him over, right? How much?
Slide it over to,
2.5, right? I have to slide him over 2.5 because this one's right here, right? So slide him over 2.5. So I have to, what's that look like in these little bracket things?
2.5,
0, 2.5 comma 0. But then after I slide him over, I have to
move it down.
over x. Okay, then if I slide him 2.5 more to the right and flip him back over the x, does that give me the third one?
Yeah.
And slide him over and flip him down, slide him over, flip him down. This combination will do all of, give me all of the 1, 2, 3, 4, 5 objects. Make sense? Good? Okay, on your homework assignment, let me show you what this looks like. You don't have this paper yet, but I want to show you this for the other people, okay? So on the bottom side, you have 5, 6, 7, 8, and your drawings, just rough sketch what your drawings are going to look like, but really I want you to focus on the describe a single transformation. Make sure you have that and you give me that part. So like number 5, if we're looking just at number 5, if I flip it over the V, I don't know, maybe something like this, right? If I flip him over V, maybe he'll look something like that. Flip him over U, whatever, back this direction. I don't know, whatever. How could I go from here to here?
Just multiply it by 2, or 2 times the distance.
2 times, what's the distance?
50-degree rotation.
50-degree rotation. So 50-degree rotation is what I'm looking for. Does that make sense?
Yeah.
Okay. So yeah, your picture can give me a rough sketch, but I'm really looking for the 50-degree rotation part. Make sense? Good? Okay. Bye, people watching this video.